Okay, so this should be the last part, and this is where we are integrating the UI. So this is all going to be in Dart and Flutter and Dart. And the way it works is, so we have Until, we have integrated the Rust part. So now we're looking at the UI. So far we have nothing. This one is also generated code, probably coming from one of the libraries. It currently has the sample code, so we can remove that, and let's take a look at what we want to do at the end. So what we have at the end is a few pages. We would have the main page would be account showing. Let me show actually the stuff. So the main page would be this guy. So there's I'm not sure if you can see it, but there's a QR code followed by, well, below there should be your Z address, your wallet address, and then your balance. So that's just the main page. It has a nav bar, a button where you can you press to refresh to synchronize. At the bottom there is a floating button where if you press you will go onto the send page. So essentially you have only two pages. You have the main account page, and you have the send coin page. So this has also the transaction history, but I will not integrate it because that page is incomplete. So let's go with the main one. So we start with the main one. We'll copy it over, and we are going to replace the existing main. Let's copy over, and let's take a look. So what you have is this part. Let's ignore it for a bit. This one I think is actually not needed, so I'm going to remove it. And we have our main thing that calls the that sets up the this widget as the main application widget. So we start with this guy, and they have two kinds of widget. You have stateless and you have stateful widgets. It's very similar to React or any UI framework on the web, which actually composes pages based on components that they call sometimes widgets, sometimes components. So the main function that you have in these widgets is the build method. This build method is responsible for setting up a tree of components that make your page. So this is like HTML but made manually if you want. This page here, what we do is this part here initializes the component with some data that is read from the bundle. So this stuff here are the assets that we put as a resource. If you remember, we had these assets here. Yeah, these assets are here, so they will be included in the package, and now we can read them with this particular API. So this reads this as binary data, and we initialize our store with this. So the store is essentially the common state of your application. Every web framework has a way to maintain application logic, application data, and then that application data is accessible from the different pages that you have. So that's where our parameters will go, and then you would have the build. So normally you could have everything. This would be the build method. So here we create the material app, which is the container for the various elements of any material UI style application. So it has a title. So I call it, what is it called? Flutter demo. Shouldn't call it Flutter demo. Let's call it Zcash wallet. Then some theme, and then the main page that you are going to show right away. So this point right to the account page, and then if you have other pages, they will be associated to some route, just like in the web you have a URL that associates a particular location to a page. Here you would have these routes. So we actually don't need the history route, and we just have the send route. So at this point, this will not compile because we don't have the account page, we don't have the send page. So the next step is to copy these two over. So send page and account page. Let's copy these guys over. Okay, so let's start with the account page. Account page. Oh, didn't need that. Remove. So the account page is a stateful widget because we are going to incorporate data coming from our store. So the only difference now is instead of deriving from stateless widget, it's stateful widget, and we have this method that creates the state. So and the state has the build. Now that the build is coming from a state, normally you could have variables here that represents the data that you will store in that particular widget, but in this case, everything actually comes from the store, from the application store. So there's no additional variables here. So let's take a look at what we have. We have our app bar that shows the cache, and we have to the right of the to the title, so still inside the app bar, we have some buttons for actions. So that's an icon button which shows an icon. So this icon changes whether we are syncing or not. So we are using this App Store syncing Boolean variable to determine whether we have an icon that's a refresh or an icon that is a pause. So this method here, which the underscore means just a private method, here says that if you are syncing and currently in the process of downloading blocks, basically, we are going to show this stop button, and then otherwise it will be a refresh button. Right, and then the action is if you press the button, we are toggling the syncing. So that's one is an action on the store, because this one will change the state of syncing. So the way this thing works is that the store will contain variables that can be observed, and when these variables change, anything that is under observer will be rebuild. So that's how you would have actually toggling the sync. Toggling the sync will change this variable, and anywhere in the UI where this variable is referred will also be updated automatically. So you don't have to keep track of this, because the store will do the tracking for you, as long as you create the proper observers, of course. The second button that you have is the button where when you press, you will go to the history page, right? So we grab the navigator and we push a new path, this slash history. But since we have removed that route, so this is not working anymore, so we can remove this. And finally, the body of the code of the page is this container, which has a padding on each side by 10 units. And inside you will have another observer, because we are going to use the address from the store and the balance. So this is actually something that we store, we keep in the store. Again, because we have this observer here, whenever the address changes or the balance changes, this will be updated automatically. So you note that all this stuff is fairly asynchronous, in the sense that when the first painting will occur, our address may not be available, where we have to query that from the Rust side. And finally, so we have this floating action button, which is a send. The icon is a send, and when you press on it, you will go to that route. So this route was defined our main page. This will send us to the send page. Okay, some zigzag here. Alright, so let's remove this because this is not the right path. And history is gone. Right. So that was the account page. Let's see if anything else is wrong here. So account page should compile. And we'll look at the send page. Send page. Okay, send page has more. Okay, so send key is not used, so remove. So the send page is essentially a form. So we have the same thing here, the same pattern where we have a stateful widget, which has a state, and this time we have some variables that are local to our state, because the form will keep the values that you input until you press send, and it will go. So this is not application state. This is state that is specific to that particular page. So we keep it here. We don't need the debug print, so we move this. And this is our main build. So this is where the page actually renders its content. So we have a scaffold. Scaffold is a general container if you won't have anything more specific. So I think this scaffold here is actually not needed. We can start with the form right away. So let me remove the scaffold and just start with form. That means this is it, like that. Every widget can have a key, and that helps the re-rendering. So I create a key for this form. Then we have a container. Again, we put some margin, 20. Before it was 10 only, I think. Okay, I'll put 20 here. Maybe we should have 10. Take a look at the account page. Yes, 10. So let's make it 10 as well here. Then the children is this column makes everything on a single column, aligned on a column. And then the column has the first row would be where we have the address input box. So the address input box is this text form field where we have a label, send to. It has multiple lines, and we have a keyboard input, multiple lines, blah blah blah. The validator would be something where it checks the address, and we have to associate this with the controller. This is pretty standard when it comes to input form fields. And then to the right of it, because this is on the same row, we have an icon that says that shows a QR code scanner. If you press on that, we're going to call the onScan method. The next row, because this is one row, right? The next row will be for the input of the currency, or the amount as a currency. So we have a currency controller, which is a money mask text controller. So this shows separators with dots and commas, and takes care of displaying currency better than if it was a pure number input box. That's from a library. That's why we import this library, Flutter mask text. Then the validator would be the check amount, and when you save, you go to the we save the amount. And finally, after that, you have two buttons on the bar. One for sending and one for canceling the operation. So let's look at the validators. We have validator to check the address. If the address field is a null or empty, so it's not acceptable. Otherwise, we call the API check address. So if you remember this guy here, it will go to our module package ZC API, which eventually calls into the Rust code, and this method check address on the Rust side. So that method is essentially the one that we have in keys here. Yeah, check address. So that will end up here, where we decode the payment address and return true if it's okay. Okay, so we can go back to this send dot. Then the check amount is very similar. So we also validate whether it's actually a real number. If it's if we try to pass this, it's not a number. This will return null. So account must be amount must be a number. Amount must be positive. No, not zero. Strictly positive, and it has to be lower or equal to the current balance. So if all these conditions are true, you return null and validation passes. If you cancel, we just pop up this page. So we will go back to the previous page. And if you press on scan, we open the scanner, the barcode scanner. So this is asynchronous because as the barcode scanner is open, the UI can do other stuff. So we are doing async here. Once you scan a code, we are going to get the value here in this barcode object, and we are setting the this barcode into the address field, which then updates automatically updates this controller, and that also updates this field here. And amount, you save the amount, right? So that's pretty much it. Oh, the send logic. So send logic, we first validate that the form is okay. So these conditions must be true. Check address and check amount must be okay. And if it's all good, we save the form. So that will save the values into our fields here. We show a dialog box. So we still want a confirmation from the user that he's willing to, he wants to do that. So that's a standard alert dialog box, which has this title, please confirm, and then this text here. And if you approve it, so the callback will be pop true or pop false. So if confirm, either way we close the alert dialog box, but if you confirm it, we return true. So this goes back to this approve guy, right? Because there's a wait here. So all this code here is gonna show this. The show dialog is gonna show this particular builder code, and the return value of this navigator is gonna be passed to this variable. Then if we are approved, we show a snack bar, which is a little pop-up at the end, sliding pop-up at the end of the screen, saying that we are sending this amount. This is just a summary of the transaction, sending this amount to this particular guy. And then we call we actually do send the value. This is where the transaction is going to be sent, right? So everything that is really business logic is going to go through the App Store, and anything that is UI is going to be done in the page itself. So finally, you pop this page. So popping this page means that whoever navigated to the send, which is actually this account button, because we push a route, we push a send route, then we will go back to the whoever calls us, which in that case will be the account page. This way of navigating means that it's very common in obviously very common in the internet and the web applications. This allows you to consider that navigation is a stack of different pages. So I think that this logic should compile that. I don't see any problem with that. And the last one here why we have problems is because we don't have the store. So let's copy the store. Okay. And the store is using MobX, which is a state management library. We should take a look at exactly how it works. But in this particular case, it's relatively simple. So we have to derive our class, abstract class, blah blah from store, and we have to have this this mix in here. And finally, we have to include that part. This is code that is generated, and at this point, this code is not generated yet because we haven't called the code generator, obviously. So this is expected that we have error here. The file does not exist. We could copy this one, but it's better to regenerate it. So what logic do we have here? We have all the state of the app, which is essentially the balance, these are the keys, right? Anything that you want to show to the UI, but you also want to be automatically refreshed if it changes, they have to be marked as observable. So some stuff is probably observable, but when it doesn't have to be, not shouldn't, doesn't have to be. For example, the phrase, which is the seed phrase, I'm never showing it. Neither the spending key. So at this point, it's really only the address and the balance that have to be observable. But just in case, these guys, I'm sure I'm not gonna show them because these are internal state. Nobody cares about what's the database path. So I'm keeping them as non-observable. And then you will have this initialize function that is called from the main page, right? So here, this is initialize. So the store will keep the bytes of the send parameters and output parameters. These parameters are used for signing a transaction. And then it will query the database path. So there's a library. We use this library SQL F-Lite, which has an API for SQLite, and in particular, we need to have the path where the database can be stored. On Android and iOS, I think it's the same. You cannot store the database in the same location as the application. Okay, so this is not needed, just for debugging. Also, we store, so this database is only used on the Rust side, and the Rust library doesn't store anything that is related to your keys. So we are storing it in the dot side. We could use a database, but that seems to be overkill for just 3 strings. Prefer to store them in the shared preferences. So there's a library for that. This is basically the application space where you can use as a key value store. So we store. Okay, so the logic here is that after we initialize the Zcash API, it should return whether we have already an account or not. So if we don't have an account, then we ask that library to create an account for us and initialize it. And the return value will be a set of keys, which will be the seed phrase, the spending key, and the payment address. So all this stuff is then stored inside the preferences. But if we don't have, we already have an account. If we don't have to do this, then we can retrieve this phrase, spending key, and address from that shared preferences. And finally, we call sync. So the synchronization will be basically the initial sync that we want to run in the background. To run something in the background is a bit. We want to run we want to run little by little. So running something on the Rust side is synchronous. We can make it asynchronous, but it's pretty complicated. You have to keep care of creating threads and making sure that there's a proper synchronization. So we're actually not going to do this in this case. What we do is we synchronize a few blocks, and then we could keep doing that in the loop until that function says that there's nothing more to synchronize. So the idea here that you have a loop where you do one step of synchronization, and this is async. So while we initiate this synchronization, the UI will be responsive. You can do other stuff, even though there's not much you can do in this app. But in terms of principle, that's what you want to do. You don't want to block the UI thread by running a long process such as synchronization. So we do this. We call this compute, which delegate to this function sync1. And sync1 here will basically try to synchronize refresh with 200 blocks. A bit arbitrary. 200 seems to be a certain number of blocks that is we're not going to do a stop and go too frequently, but it leaves enough time for you if you press your user presses stop to quit this synchronization. So here actually is the code is a test for synchronization. So what we should have is also end syncing. So this allows us to abort the syncing by clicking on toggle sync. Right. So the logic here is that you go here, you do this compute. This will do the await. Await will relinquish control out. If you have the user presses on toggle sync, on the button sync, this will turn syncing to false, and then we go back here after that particular 200 blocks. Right, we come back here, and we notice that syncing now is false. We get out, which allows us to abort after a chunk of 200 blocks. This is this is kind of cooperative cancellation, which is basically what the best you can do, because there's no way for you to abort a thread on the native side without letting the application be in the inconsistent state. So we have to make sure that the app remains in this at the proper checkpoint. So after every 200, we update the balance by reading on the other side the current balance. So it's in Satoshi, so we have to divide by the 100 million, and then we loop, and unless you have no more blocks. So we have to we stop if the block is 0, or if you have decided to stop syncing, in which case syncing is now false. Right? So the toggle sync is this button, the callback for this button. Which is done here because it uses variables that are observable. Right? Again, everything that is observable and have every action that is have an impact on observable. Sorry, they have to be marked as actions. And then you have also. So this logic here is all you take for the sync. And for sending, same logic. So we want to send. So this is the call is made to send an amount to this particular address. Right. For this, we also use a compute. Compute is basically a way to do a background task. So we freeze the UI task to do something else, and this function send1 will be executed in another isolate in another kind of like another process. The signature though is required that send the function that you call must be a function that only has one parameter. So since we need many more parameters, we need address, amount, a bunch of we need the zk-snark parameters. I need to put that into a message. Just store that as a class. So that they can be passed to this send1. So send1 is unpack them and then calls the real guy. Right? So the logic is very simple here. This whole thing here is to say that we essentially are calling this function, but we can't call that function completely directly because we want to have it done by a background task. So this is the whole logic actually for the app. So at this point, if we save this, everything should be okay. The only thing that now is we left to do is to generate this this code here. So for that, it's Flutter what actually? Flutter something build runner. Okay, build runner. Okay, so this is the command. Flutter pub run build runner build. There are other options, so commands. So this actually, this whole thing here just say that this is a package, and one of the packages is called build runner, this is the one that's going to run the code generator, and this is build. So we are building the new generated code. There's other stuff like you watch, which automatically invokes a new code generation whenever it basically watches your directory. If you make a change, it will regenerate the code. But we don't need to do this we don't need to do this right now. I guess it's more convenient if you are essentially developing the code. Okay, so this code has been generated, right? So this is the whole thing here. So don't need to look at that. It's code generated, and everything is ready. So the application is complete, and we can run it. There's one thing that we haven't done, which is kind of obvious that's missing, is so for all this stuff, especially the native side, is compiled only for PC, for this environment, and nothing here is gonna work because it's not compiled for your phone. So we need to have to use this makefile. So I'm gonna copy over this makefile that again I got from forgot where. But this makefile, what it does is it goes through this particular directory, the native CCPI, and this is the root project for the Rust side, and then it will go and create the compilation compile for different architecture. So I'm compiling just for ARM because my phone is ARM. But you can compile with a different target here. So task build is the one, and the main one. You can include iOS targets. So you can, for example, if you do like Android and iOS, like this one, this will compile for both platforms. But this guy has to be run from a Mac. It can't be done on a PC. So here, right, if you want to do all Android targets, including x64, you replace this one with Android. So that being said, all you need to do now is do a cargo make. What's going on here? Could not find cargo. Okay, so two things. Also need to copy the Tomo. So notching here and cargo make. Right. So this will compile our Rust dependencies. This one is going to be compiled for ARM. The 3 different variants of ARM. So it will be compiled 3 times. Okay, and one more thing is to the makefile, to add this section here so that the bundle is created as a the library is created as a shareable library and not it has to be a sole file. Alright, so we do this, and here we can do C3 cargo make. Okay, that creates the first one. Oh, this is the first one. I think it's the second one there. Okay, that's with the third one. If you want to create for release, you have to do profile release, something like that. We don't need that here. And now we should be able to run it. So where's the phone? The phone is here. If you do the change only on the UI side, so on the dot side, it is even faster because you have hot reloading. But since this is that particular change is in C or in Rust, we have to rebuild. So it takes like maybe less than a minute. Okay. Okay, so now we have to clear the app. Let's do that. Let's clear the app state. Before storage, clear storage, and then we run. All right, so now it works. Hopefully you can see that we have a new address, and we have a QR code, and then the rest should work. All right, this time this is really the end. Okay.